kids, welcome to my channel Hi with Himani. We are doing a second chapter from class 6 mathematics, that is whole numbers. In whole numbers we have already covered the number line and what whole numbers are, what natural numbers are, that's we have already covered in detail. So today we will do the topic properties of whole number. The 4 properties which we are going to do, they are fairly simple. But the problem lies in remembering them. Often the students gets confused which property stands for what. Okay, so in this video, if you will be with me, I will tell you simple tricks, simple mnemonics, visual mnemonics to remember these commutative properties. So the 4 properties that we are going to do is, first is the closure property, second is the commutative property, third is the associative property, and fourth is the distributive property. So shall we start? The first property that we are going to do today is the closure property. To remember what closure property actually is, you just remember this lock. A simple lock. Everything is closed. कोई कहीं नहीं जा सकता, सबको यहीं रहना पड़ेगा. Simple. इसका क्या मतलब है? What sense does it make? Let's see this. So we'll do first the closure property of addition. What does it say? It says that if A is a whole number, B is also a whole number, then A plus B, that is C, will also be a whole number. That is, if Papa is Mr. Gupta, Mummy is Mrs. Gupta, then child is Master Gupta. It cannot be anyone else. Simple, closed, a close-knit family. That is known as the closure property of addition. So can we check this? Let's take 2 numbers. 2 plus 4 is equal to 6. We all know that 2 is a whole number, 4 is a whole number, and 6 is also a whole number. Then, if we reverse the order, right? 4 plus 2, 4 is a whole number, 2 is a whole number, 6 is a whole number. So, whichever, and we can take, suppose 14 plus 12, it will still hold true. Then it will be 26. This is all these 3 numbers are whole numbers. Closure property. No one is going anywhere. Sab whole numbers ke hi paas hai. Simple. Now we'll talk about the closure property of multiplication. You just have to remember lock and closed. Same thing. A is a whole number, B is a whole number, then the product of A and B, that is C, will also be a whole number. 3 into 6. 3 whole number, 6 whole number, then the product is 18. Is a whole number. We can do with 25. 25 is a whole number. 8 is also a whole number. 25 into 8, we know that it is 200. Is also a whole number. It doesn't matter, you are taking a smaller whole number or a bigger whole number. The property will always remains the same. So here we have done a closure property of multiplication. Now, we need to check, is this closure property true for subtraction also? If 4 is a whole number, 2 is a whole number, then the product will be a whole number? Yes, in this case it definitely is. But now if we reverse it, 2 minus 4 minus 2. Minus 2 is not a whole number. So the closure property does not stand true for subtraction. I hope this is clear. We can test this for division as well. So 4 divided by 2 is what? 2. 4 is a whole number, 2 is a whole number, and this 2 is also a whole number. Simple. It is standing true. But if we reverse the order, do you think it still stands true? This closure property? No. 2 divided by 4 is 0.5 or is half. It is not a whole number. So, closure property only stands true for addition and multiplication, but it does not stand true for division and subtraction. Simple. Closure property is clear? Yes. So we are done with closure property. Now we'll talk about the new property, commutative property. You just remember this word, commutative. With commutative, it is easier for you to remember commute. Commute means to travel, on regular basis, like the way you commute in your school bus to your school. So similarly, see, if you are going to school, does it matter if you are sitting on the first row or the last row? Does it matter? Like where you will land up or where your destination is? If somebody is sitting in the first row and someone else is sitting in the second row, do you think that they will reach different destination just because of their position? No, of course not. So similarly, here also, the numbers will also land up at the same place, no matter in which order they are placed in the operation, in the mathematical operation. So, we'll first do the commutative property of addition. What does it say? It says that if A plus B are added, the sum will be equal to B plus A, sorry. That is, if we have added A, then we are adding B, the answer will be same if we have added A to B. By changing the order, the answer will not change. Very simple. 3 plus 2 is equal to 2 plus 3. It doesn't need any explanation. 5 is equal to 5. Simple. This was fairly simple. So let's do the commutative property of multiplication. It also says the same thing. If we are multiplying A into B, the product will be same when we multiply B into A. By changing the order, the answer will not change at all. 5 into 2 will be equal to 2 into 5. Do you think it will change? 5 to the 10, 2 5 is also 10. Simple. Now, we are done with the commutative property of addition and multiplication. It is, quite logical that this property will not hold true for subtraction and division. Do you want me to do it? If 4 minus 2, do you think 4 minus 2 and 2 minus 4 will be the same? Definitely not. 4 minus 2 is 2 and 2 minus 4 is minus 2. It is not equal to each other. So it does not hold true for subtraction. Similarly, it will not hold true for division also. We can take, you will say again and again, you are taking the same example. Let's take 50 divided by 10. Will it be equal to 10 divided by 50? No, it will not be equal to. So, commutative property just holds true for addition and multiplication, but it does not hold true for subtraction and division. Simple. Remembered by the word associative or association. So, association is like grouping. In this, they're saying irrespective of the association of the numbers, the result remains the same. Like, it doesn't matter if A is getting associated with B first and then with C. The answer will remain the same if C and A gets associated first and then with B. Is it complicated? No, it is not. So let's understand them, one by one. The first is the associative property of addition. What I was saying is, if A associates with B first, first they get associated, and after that they get associated with C. The answer will be same if A and C gets associated first, if they make friends first, and after they are friends, then they become friends with B. Here also all these three are friends, here also all these three are friends. It doesn't matter who becomes friends first. Is it true with you also? So let's take the example of these numbers. It's like this. If 3 plus 2 and then it's 7. 3 plus 2 is 5. 5 plus 7 is 12. Here if we do it, 3 plus 7, we'll do 3 plus 7 first. Do you know 7 and 3 are friends? You know, friendly numbers? The numbers which together, their sum is 10. 7 and 3, 9 and 1, 6 and 4, these are all friendly numbers. I try to, remember those numbers. It will really help you in your calculation. So, if I add 3 plus 7 and then 2, then also 3 plus 7, as I told you that these are the group of friendly numbers, it's 10, and then 2 is added to it, it's 12. See, it's same. It is not different. Yeah, there is this silent bell going on. I hope it's not disturbing you. So let's take a different example. I was asked to add 96 plus 12 plus 4. So I can do this. I can add this first and then I can add 4. But since I know that the associative property is true for addition, I will say that this will be equal to 96 plus 4 and then 12. I know 96 plus 4 will give me 100 and plus 12 means 112. It has made my calculation comparatively easy or not? So associative property, it's not, just to remember and mug up and just write in your exams. It is really very helpful and a practical property. This is associative property of addition. I hope this is clear. Association. So adding 96 to 4 makes much more sense than adding 96 to 12 and then adding the entire thing to 4. Now another one is associative property of multiplication. What does it say? If A is multiplied to B and then the entire product is multiplied to C, it will be equal to if A is multiplied to C and then the entire product is multiplied to B. It is same. So let's check it. 5 into 3 into 4 will be equal to 5 into 4 into 3. Which one you will prefer to calculate? 5 3 is 15, 15 4 is 60. 20 into 3, 60. In both cases, the answer is same. So this is the associative property of multiplication. Again, this is quite helpful if we, to simplify our calculations. For example, I have to multiply 5 into 6 into 8. Then what I'll do is, I will do 30 into 8 is equal to 240. This is one way I can calculate, or I can also calculate is like this, like, I've calculated like this. This time I'll calculate it 5 into 8 into 6. Which one you will prefer? Tell me. 40 into 6 or 30 into 8? The answer is 240. It's same. So this is the associative property of multiplication. It is quite logical to know the same thing. This property does not hold true for subtraction and division. It only holds true for addition and multiplication. So now we'll do the last property, that is the distributive property. How one thing is getting distributed with the other two doesn't really matter. Other two or other three doesn't really matter. Does it making sense? I'm sure if not. So let's do it with these examples. So what does it mean? As I told you, that how one thing is getting distributed amongst the others, the order does not matter. Like if A is getting multiplied by the sum of B and C, if this is the case, A is getting multiplied by the sum of B and C, then it will be equal to if A is getting multiplied by B first and A is getting multiplied by C, and then we add both of them. It will be the same. What we have done over here is A is first getting multiplied to B, then it is getting multiplied to C into C, and then we are adding both of them. So this is the distributive property of multiplication over addition. Let's take a simple example to understand this. 2 into 3 plus 5 is equal to 2 into 3 plus 2 into 5. 2 into 8 is equal to 16. 2 3 is 6. 6 plus 10 is also equal to 16. See, 16 here also, 16 here also. This is the associative property of addition. This is a very interesting property and again a very practical one. And again a very practical one. How? Once my teacher gave me a fairly complicated, problem to solve. 96 into 1001. One thing I could have done is I could have written 1001 multiplied by 96, the traditional way. Or I can use this property of addition. Do you want to try it on your own? So if you want to, then just pause the video, try it on your own with the distributive property, use your brain and try to do it on your own. Take time. And then again restart the video and solve it along with me. So, shall we start? I will use the distributive property like this. Can I say 96 into 1000 plus 1 is equal to 96 into 1000 plus 96 into 1. Can I say this? So this will be 96,096. which method you would prefer? Don't you think it's fairly very simple? What do you say? I really feel that this is very simple. So now we'll do it. We'll do this distributive property of multiplication over subtraction. What does it say? The same thing. If A is getting multiplied to B minus C, then it will be equal to, if A is getting multiplied by B and A is getting multiplied by C and we are subtracting both of them, it will be the same. Again, suppose earlier the question was 96. Suppose the question is like this time, 96 into 99. So many 999s. I will again use this property. What I will do is 96 into 99 I have to do. I can write 99 like this, 100 minus 1. Is this okay? 96 into 100 minus 1, is this okay? So I will write 96 into 100 minus 96 into 1. So 9600 minus 96 will give me 9504. So these are very, very interesting and helpful properties. I hope this is clear to you now. So can we have a quick glance of what we have done? The table is right in front of your screen. I want you to fill it up on your own. That does closure property stands for addition, subtraction, multiplication and division. And again restart the video and check along with me. Closure property stands true for addition. It does not stand true for subtraction, multiplication, but not for division. Commutative property also for addition. Associative property is also for addition. And both these property does not stand for multiplication or subtraction. Stands true for multiplication but does not stand true for division. Now at a quick glance, let's revise them again. What is the closure property of addition? It states that A plus B is equal to C. If A is a whole number, B is a whole number, then C will also be a whole number. If A is a whole number, B is a whole number, then the product of A and B will also be a whole number. So this is the closure property of addition and this is the closure property of multiplication. For commutative, commutative is in which manner it is written. If A plus B is equal to C, then B plus A will also be equal to C. In other words, we can also say if A plus B will be equal to B plus A. Similarly, here we can write A multiplied by B will be equal to B multiplied by A. It doesn't make any difference at all. So this is the commutative property, in which how we are commuting doesn't matter. What matters is that we are commuting. हम स्कूल जा रहे हैं ना, वो मैटर कर रहा है. हम बस में आगे बैठे हैं या बस में पीछे बैठे हैं, इससे कोई फर्क नहीं पड़ता. टाइम पे हैं हम. That really matters. So if you talk about the associative property, it says if A and B are added first, then they are added to C. It will be the same if B and C are added together and then A. This is the associative property. This is the associative property of multiplication. A and B are multiplied first, then they are multiplied to C. The answer will be the same if B and C are multiplied first and then they are multiplied to A. As you can see, the battery of my laptop is running low, but no worries. We have completed, our 4 properties. So See you in our next video. The next video will be a very short one that will be based upon the multiplicative identity and the additive identity, right? That will be the last topic for whole numbers. Okay, so see you again in our next video. Thank you so much for watching.